Hey everybody, happy end of April. I hope you had a great weekend. That weather was great outside. Really enjoyed that sunshine. And we have a very short week to this week. Not a lot for you to do, just really a lot of review. Our essential question is, where can you find the example of the law of conservation energy in your life now? Don't forget to do the do now, please. Always we want to start with that. I'm just going to review some key terms, and then I'll give you kind of an example of how might see the law of conservation of energy in your world. And all I really need you to do is take a photo or a video of it explaining it and use all the key vocabulary and post that. There's no participation quiz this week other than the do now. It'll all be done on our Google document. So let's go through and just pay attention to a couple of things. Remember the law of conservation of energy. Energy cannot be created or destroyed. It means the total energy in the universe doesn't change. We talked about this in a few other videos. All the chemical energy that's down here in the TNT gets converted into kinetic, potential, and heat energy as a projectile flies through this. But the total amount of energy of the kinetic, potential, and heat energy has to equal the chemical energy that went in. No different than for the food. The amount of chemical energy in your food has to equal the amount of energy that comes out of your body, mostly as heat, but also as carbon dioxide, water, and of course the energy that runs you. Your metabolism lets you hear what we're saying. So don't forget some key terms, system and surroundings. Had some feedback on this. Remember, the system is just any part of the universe that you choose to focus on. So maybe I would be lighting a match and I would say the system is the match. The surroundings then is just everything else. Whatever's around that match, including my hand that's holding it, including the air or the candle wick or whatever I'm trying to light, that's all part of the surroundings. And the total energy lost by the match has to equal the total amount of energy gained by the surroundings. That's the law of conservation of matter. In the system in chemistry is always the chemical reactant. So to be honest, the system in this match is the bismuth salts that are actually lighting up upon friction and burning. That wood that's in this candlestick actually is part of the surroundings that's being put into the system. That's a lot of detail, but you just want to be clear. Identify what you're looking at as the system, and everything else is the surroundings. And of course, we have words that describe that movement of energy, endothermic and exothermic. Remember, if the energy leaves the system and goes into the surroundings, it exits. That means a burning candle is exothermic. There's energy leaving the system and going into the surroundings. If it's endothermic, think of like a cold pack. If there was a cold pack right here, the energy would be going from your hand into the cold pack. Your hand would feel cold, and that's what an endothermic change when it enters the system, when it takes heat away from the surroundings and puts it into the system. So endothermic feels cold, exothermic feels warm. That's a simple way to think about this. So these are a lot of examples of things as being endothermic or exothermic. Here's the system. Here's the system. Here's the system. There's the system. The system. The system. This whole hot pack is the system. The cold pack is the system. The cake batter is the system. When you think about these things, when a firecracker goes off, is it endothermic or exothermic? Take a second and think through what you think each one of these is, endothermic or exothermic. Let's go through the answers just briefly. Um, Firecracker gives off energy to the environment. It explodes the light and sound. That's exothermic. Boiling water, I have to heat it up. I have to put the energy in. That's endothermic. Cooling the beverage. When I cool a beverage, I have to take energy away from the beverage. And so that's exothermic. When I melt butter, I have to put energy into it. That's endothermic. When we digest food, we talked about that. It gives off heat energy. That's exothermic. When I burn a candle, it's releasing heat into the environment. That's exothermic. A hot pack, exothermic. A cold pack, endothermic. Baking a cake, when I put heat into the dough or the cake batter, that enters and it ends up making the cake. So what you want to do is understand those key terms: system, surroundings, endothermic, and exothermic, because here's what I want you to be able to do. I want you to identify, describe an example of the law of conservation of energy in your world. In this week's assignment, the only thing you have to do is our Google Doc that you can see right here. And in this Google Doc, here's our essential question. Here are our key vocabulary terms right here. And what you want to pay attention to is just some 5 questions. In those 5 questions, I've added a few problems, the last unit, just to make sure that you can review and remember how to do that. But the law of conservation energy, you got to learn a little bit about calorimetry. It's kind of how we measure whether it's endothermic or exothermic. And here's all you have to do this week. Take a photo of the video, an example of law of conservation, and insert it right here. And describe your example of how, make sure that, describe how that is either endothermic or exothermic, and it's your example of the law of conservation of matter with the words system, surroundings, endothermic or exothermic used correctly. Don't forget to always do a reflection right here at the very end. And let's talk about this. This is an example of an exothermic change that's going on in my world right now. We've had fires out in the backyard. Right here is the system. The system is the wood that's undergoing a chemical change. Everything else is the surroundings. These plants in the background, the grass, even the smoke is in the surroundings. This is exothermic because there's energy being given off from the system to the surroundings, and I used some of that energy to actually cook a marshmallow the other day. And when I cooked the marshmallow, that was endothermic. The energy was leaving, the energy was entering the marshmallow to toast it. So that's something along the lines that I would like you to do. I would like you to take a photo or a video, and in the video you can explain, or with the photo and you can type right your answer, what's going on with this. So that's our week. Pretty simple. Review a few things. Really, I'm just curious to see what you come up with from this. I read a lot of the ones that you guys said, and so I'm really looking forward to that. Take care, and we'll hear from you over the course of the week. Please remember to do the do now for attendance. Understand Monday mornings are when I start looking into things, and so take good care. Get in touch with any concerns that you have. Take care. Bye.